So today we're going to talk about proportions. Okay, last time we talked about what? Ratios. Turns out, and ratio is an expression, really, isn't it? Okay, so if a ratio equals to another ratio, guess what that's called? Hint, hint. Yeah, that's a proportion. And so ratio is an expression. You see how you have the expression equal to another expression? What is that? That's an equation. So proportion is an equation. Okay, that states that ratios are equal. Okay, that's what a proportion is. So write this down. Okay. So that's what we'll be talking about today. Okay. Here's an example of a very simple proportion. This time it's not that interesting though because it doesn't have any variables. But 2/3 equals to 4/6, right? I could write it as a this way or this way, right? Same thing. You could write it as a fraction. 2/3 equal to 4/6, or 2 to 3 as to 4 to 6. And that's, by the way, that's how you read it. Okay, when you have something like this. Okay, 2 is to 3 as 4 is to 6. Okay, so very simple. All right. What would this be? 2 is to 3 as, how about, I don't know, 6 as 2? 9, very good. We can multiply top and bottom by 3. Anyway, that's the idea. Okay, let's move on. This is the key idea for today. If you have a proportion, A over B equals to C over D, then, of course, you're going to have some variables, and so forth. And to solve this equation, there's a nice thing you could do. Turns out, if you have A over B equals to C over D, ratio equals to another ratio, where we have a proportion, then do we like equations with denominators? No. So there's a simple way to fix this so that you don't have any denominators. Oh, some of you already know. Okay, it becomes what? AD is equal to BC. Turns out, if I want to multiply A times, right, denominator of the second fraction, it'll always equal to numerator of the second fraction times the denominator of the first fraction. I bet a lot of you have seen this before. What is this called? Cross multiplication. They call it cross multiplication. It's a shortcut, really. It's because what? It's because it looks like a cross. You see how you get a cross A, you get X, right? A times D equals to B times C. This is always true. It's a shortcut. So this shortcut you'll be using today. Okay. Of course, this shortcut only works if you have what? Fraction equals to another fraction. Ratio equals to another ratio. Right? That's the only time it works. So you get to use this shortcut, but of course, I'm not just going to give you the shortcut. You have to understand this algebraically. Why does this work? It says, why does this work? How can you explain this algebraically? Because there's nothing in algebra that says you can multiply the numerator times denominator of the other one, and then, right? Why does this work this way? This is a shortcut. This only works if you have a fraction equals another fraction. Anybody see it? Oh, 2 people see it? Tajwa, what do you think, sir?
Because since it's equal,
yeah?
the A and C are being near the same. So they're,
I'm not saying.
But they're the same amount. And so if you put them into LCD, then they're both.
Oh, I showed you the answer. Yeah, it has to do with the LCD. What am I doing with the LCD? Sorry, I showed you. Because look at the first example. Look, 2/3 equal to 4/6. Let's see if it works. What is 2 times 6, guys?
12.
What's 3 times 4?
12.
You see, it's going to work every time. Why does this work? And you're right, it does something to do with LCD. Well, how is that? Dana, what do you think? You're right. You're multiplying both. What is the LCD of these two fractions? BD. Guess what happens if you multiply both sides by BD? The denominators will cancel out, and look, the B's cancel out with the B. What's left here? What's left? If the B's cancel out, what's left? Yeah, AD, right? Right? Multiply this side by BD, the LCD. What happens with the D's? They cancel out. What's left? B. Yeah, so that's how you get AD equals to BC. And so this shortcut works because of what? What property of algebra? Multiplication, property of equality. What does it say? What does multiplication property of equality say, guys? If you have an equation, you can multiply both sides of the equation by same number. This time, what are we choosing to multiply both sides by? BD, which is the LCD of these two fractions. A, B, right? A over B and C over D, right? Isn't BD the LCD? So when you multiply both sides by the LCD, what happens to the denominators? They cancel out. You just get this. that make sense? We'll do some examples. It'll make sense in terms of why we do this. But do you see why this shortcut works? Why we get, if you have this fraction, a over b equals to c over d, do you see why it equals to ad equals to bd? Right? You're basically multiplying both sides by d, else to d, right? So they cancel out. Okay, some of you are saying, wait a minute, don't we have to have a common denominator and so forth? When do we need common denominators, guys? When you are adding or subtracting fractions. Is that what we're doing here? No. We just simply have a fraction equal to another fraction, right? If you have that, right, then all you have to do is multiply both sides by the LCD, or use this shortcut, right? Use the cross multiplication, and the equation becomes a lot simpler than what we had before. You see how it became a lot simpler? Now you don't have any denominators. Does that make sense? Let's do some examples. See if there's no hope. Okay, that's this. All right, take a look at example 1a. Do you see we have a ratio equal to another ratio, right? We have a proportion, don't we? We got a fraction basically equal to another fraction. When this happens, right? To solve for x, we don't want any denominators, right? There's a nice way to get rid of all these denominators, 3 and 12. That's what we're going to do. Multiply both sides by 3 times 12. When you do, it's same as taking that shortcut, which is the cross multiplication, right? This will become what? X times 12 would equal to what? 3 times 5. Do you see the shortcut? X times 12 would equal to 3 times 5. Right? Yeah. Yeah, look, x times 12. I'm telling you, the shortcut tells us that if you have a fraction equal to another fraction, all you have to do is multiply x times 12, which would equal to 3 times 5. And let me show you why this is true. Yeah, which is 15. Yeah, let me show you why this is true. Because all we're doing is multiplying both sides by what? 3 times 12. Isn't that the...
Wait, what? It's so hard for you. No, I know how to do it. Wait, why can't we just do cross multiplication? I know.
Okay.
Even I get it.
Okay. I want you to talk with your group, see if you can help each other out. Some of you are really confused. Oh, wait, go ahead. All right, so a lot of you kind of got this now. That's good. I'm glad. Okay, so turns out all we did was just, okay, if I go from first step to the third step, all we did was just, what did we do here? What did we do? We did cross multiplication. We took that shortcut. What's this in the highlight? That's the work. The work. Do you have to do this work every time? No. I'm just showing you where this shortcut came from. Is that okay? Does that make sense?
Yeah.
So I'm just showing you where this is. I'm basically multiplying both sides by 3 times 12. That guarantees all the denominators will go away, right? And, well, what's that same as? It's same as doing the cross multiplication. Is that okay? So, of course, I'm not done here. And what's the whole point of this, Eric? I'm trying to solve for x. And look, the first original equation has some denominators. Now, once you do cross multiplication, you don't have any denominators. That's why it's nice. You see? And all you have to do is divide both sides by 12. And you get 15 over 12. What's the answer? Is this the answer?
No.
No, you want to simplify 15 over 12. What goes into both 15 and 12? 3. So the answer is 5/4. Okay, does that make sense? Thank you. Does that make sense? All right. What does this answer represent? The question is, what does x equal to 5/4 represent? Anybody know what that represents? Yes. I'm sorry? Yeah, okay, 5/4, you could think of it as a ratio, but what does x equal to 5/4 represent in this case? Tajwa. Right, but what does that mean in terms of this equation, this original equation? We had x over 3 equals to 5 over 12. Dana? Exactly. If you were to plug in x equals to 5/4 here, it's kind of you get 5 over 4 all over 3. It's not really a simplified fraction, right? Turns out that whole thing, if you simplify it, equals to 5 over 12. That's what we found. Left side, if you plug in x equals to 5 over 4, the left side would equal to the right side. That's what we found. That's what a solution is, right? Good. Okay. Any question? Okay. So if you got this, try this one yourself then. How would you solve for x? Now, can you use that shortcut? Yeah. But is it good to know why that shortcut works?
Yes.
Yeah, so you don't have to write that work if you don't want to, but I'm going to put it there for you to see it, okay? But yes, you could just take that shortcut, but it's always good to know, right, where that shortcut comes from, right? It's really basically multiplying both sides by the LCD, right? All right, go ahead, everybody finish this stuff. Solve for x here, okay? I'll wait. Okay, so who could tell me what we get after we take this shortcut? By the way, does the proportion on the left and the proportion on the right, do they look exactly alike? No, they look a little bit different, even though we use sort of same numbers. Turns out, you get the same answer. Anyway, what is it that you get when you take the shortcut? How about, yes, Michael?
15 equals 4x.
Yeah, 15 equals 12x, which is what we had before, right? And look, I'm showing you that work. Do you have to put that work in your homework tonight? No, you could just take the shortcut, but I just want you to know where I got that, okay? Shortcut is a lot easier, right? Okay, so then we get, of course, the same thing. 15 equals to 12 over x. Divide both sides by 12. Same exact answer. Are you okay?
Yes.
All right, so these are pretty straightforward. Let's practice some more with doing the shortcut again. Okay, let me give you another example. Okay. Here is example 2. By the way, if you want to take that shortcut, you have to check and see if you have a proportion, right? In other words, if you have a fraction equals another fraction. Do we have that? Yeah, so could we take that shortcut? Yeah, so we got 3x plus 1 all over 5 equals to x over 2. So go ahead and take the shortcut and figure out what x is. And I'll wait for you. Go ahead, everybody, try. All right, Royce, what did you write down for the second step?
I wrote down 6x plus 2 equals 5x.
Oh, you actually multiply that. But yeah, you get 2 times 3x plus 1 equals 2 5 times x, right? And here I show the work. Is that okay? Is this good thing to see? Yeah, you should know this is what's going on, right? Because sometimes when you take the shortcut, right, if you forget what to do, or if you don't understand what you're really doing, right, it's easy to make a mistake, and that's how we get that. You're basically multiplying both sides by 5 times 2, right? The 5's cancel out, 2's cancel out, okay? And that's what we get. And like Roy says, when you distribute, you get 6x plus 2 equals to 5x. And of course, what do we do next here? How about Aiden? How do we solve for x now?
We subtract 6x from both.
Yeah, you could either subtract 6x from both sides or 5x from both sides. I normally ask you to subtract 5x, one that's smaller. So let's do that. And then if you do, you get 0 on the right side, right? 5x minus 5x, same thing. How many forgot? And then you subtract 2. You could do it the other way. How many forgot negative 2 as the answer for x? Easy enough? Okay. So that's how you use the cross multiplication. You have to, of course, understand why you could take that shortcut. Does that make sense? You need to know that algebraic step. Okay. All right, go ahead and try example 3. It says x minus 5 over 12 equals 2. X plus 2 all over 5. Same exact sort of thing that we did before. Can we use the cross multiplication here?
Yes.
Yeah, we have a fraction equals to another fraction. Okay, whenever you have that kind of equation, it's easy to get rid of all the denominator. Then you can't do that. So
What if you go over 1?
yeah, then you could do it. So you can make it into yeah. Uh-huh. But sometimes you could have like 2 fractions on the left and then one of them on the right. Then you will want. You know what I mean? You can have one fraction equals another fraction. Yeah, you could add and so forth, but it may not be the easiest way. You know what I mean? So be careful. All right. So let's see if you really understood this. Brandon, can you show me? Okay, we're gonna do the cross multiplication in a minute, but why do we get that result? We can multiply both sides. We're really basically multiplying both sides by what? Yeah, LCD 12 times 5 in this case, right? So when you do, what do you get? Tell me what you write.
I got 5x minus 25
Mm-hmm.
equals 12.
Good. All right. So this is the work that's really going on. What's really going on, right? You're multiplying both sides by 12 times 5. So 12's cancel out. Here 5's cancel out. So you get 5 times x minus 5 equals to 12 times x plus 2. You actually multiplied it out, and you're right. This is what you get. All right. And of course, when you do the whole thing, when you solve for this, Camila, what did you get as your answer? X equals to negative 7. Let's see. I subtracted 5x from both sides. And of course, you get negative 25 equals to 7x plus 24. Okay, and subtract 24. Then you get negative 49 equals to 7x. Divide both sides by 7. Negative 7 is the answer. Correct?
Yes.
How many got negative 7 as your answer? Very good. Okay. All right. So here comes your favorite part of the section. Yeah, the word problem. There you go. So write this down. Okay.
Mike, calm down.
Thank you. All right. That's good. An investment of 12,000 paid interest of $102. Okay. How much interest would 1,600 invest at the same rate for the same amount of time to pay? Okay. That's the question. So if you invested 1,200, you get $102. They're asking if you then were to invest in the same under the same condition. If you invested $1,600, how much would you get? By the way, would it be more than $102 or less than $102?
More.
It'll be more because you're investing more, right? By the way, when you do this kind of word problems in this section, what kind of equations would you expect to get? Think about it. What are we talking about today? We're talking about, right, proportions. So do you think it's a good idea do you think it's likely that the equation that you get is going to be a proportion? Okay, so keep that in mind. So write this down. Of course, this word problem, so you got to do all 5-step plan, right? So go ahead and read it. See if you can figure out the unknown, and see if you can declare a variable, and then we'll go from there together, okay? What is the unknown in this case? How many unknowns do we have, first of all? Matthew? One. And what is it? What is the unknown, Matthew? Yeah, for interest, how much you will get after investing $1,600. So that's what I'm going to write down. Now, as we said before, we're expecting this equation that we get, right, will look like a ratio equal to another ratio. In other words, a proportion. So do you see any ratio? So how much do we get for investing 1,200, guys?
102.
102. You see that's sort of a ratio. Okay. So look, for investing 1,200, you get $102. What do we get for investing then $1,600? You get how much? X. That's the unknown. So can somebody, knowing this is what we have, right? This is our data. Can somebody give me a proportion using this? Because that's what we're going to get. What sort of proportion would you get here? Aaron, what do you think?
1,200 over 102 equals X over 16.
Is it going to be X over 1,600? Because you said 1,200 over 102 equals to?
Wait.
You
1600.
exactly. That's important, isn't that right? If you switch those around, it doesn't make any sense, right? It's not a really good ratio, right? You're doing ratio of how much you invested over how much you get, over how much you invested over how much you get. Does that make sense? Because this is under same condition. So therefore, this is the ratio you get. Now, could you have done it the other way, where you did? So Aaron told me this one, 1,200 over $102 equal to 1,600, right? Over X, right? We're putting on the numerator how much you invested. Now, is it okay if I put down on the numerator how much you get instead of how much you invested? Yeah, same thing. But if you're going to do that, guess what? On the right side, you have to do the same thing, right? $102 over 1,200 equals to then what would you write? What would the X over 1,600, right? So it doesn't matter. You could do it either way as long as you're consistent, right? You can whatever you start off on the numerator, the other one has to have the same, right, thing on the numerator, right? Go ahead, everybody try to solve then, either this way or that, and you should all get the same answer. Go ahead, everybody try. All right, so I multiply both sides by the denominators, right? Or I could just do cross multiplication. So don't you get this? 1,600 times 102 equals to 1,200 times x, right? Now, I'm not going to multiply 1,600 times 102 right now because I'll be dividing both sides by what? To get x by itself? 1,200, right? Because I want to leave a factor. You guys remember? Because you can now simplify things. You see what I did there? What we're going to 1,600 and 1,200? Well, 100, right? And then you can also divide. What goes into 16 and 12? 4, and so forth. So I did that. So I divided by 100. I get 16 over 12, and of course, I can keep simplifying, right? 4 goes into 16 4 times. 4 goes into 12 3 times. Does 3 go into 102? That'd be nice. Does 3 go into 102?
Yeah.
Yeah. How do I know?
Did you add?
Yeah, you add 0, 1, and 1, 0, and 2. You get 3. So 3 has to go into 102. 34 times comes out. The answer is, how many forgot the answer as? 136. Yeah.
I did it.
That's complicated.
Really, all I'm doing is simplifying this fraction right here. I first divided top and bottom by 100, and divide by 4, and then divide by 3.
Guys, the same way to do it is you multiply them out and then you just.
Yeah, you can multiply it out and then divide, but which is easier?
If you have a calculator.
Well, you can't use calculator. So there you go. Now, does it make sense? Was it more than $102 that we expected? Yeah, it came out more than that, right? Does this make sense? So obviously, if you invest more, right, under the same condition, you will get more money. There it is. Do you see what to do for tonight's homework?
Yeah.
Guys, on tonight's homework, what do you expect to get as the equation? A proportion. Does that make sense? All right, very good.